The last section we're going to look at in chapter 2 is 2.5, and it's on solving inequalities like we did last time, but higher order means that it could be like quadratic. We can still do those by hand. If it gets higher than quadratic, we'll look at we'll use the calculator. Okay, so I'm going to go back to a formula I think we did in chapter 1. Okay, it was the formula for projectile motion. Okay, so I'm going to put that up on the board again. If you need it, you can copy that down. And that formula is based on using units of feet and seconds. Okay, so if you're using different units, you do have to adjust that. We're going to stick with feet and seconds. What would change is the negative 16. It would change to a different number. Okay. So what we found in chapter 1 is a time when, say, an object being launched was at exactly a certain height. What we're going to look at now is maybe when is the object greater than a certain height, or less than a certain height. So a little bit more complicated than just a regular inequality because it does have an exponent of 2. So if we're going to figure that out, we're going to have to show you a method for solving an inequality that has an exponent of 2. Okay, you can't just directly use quadratic formula because it's not an equation. And the other thing that comes up with inequalities, if you divide by a negative, you need to flip. So we've got to take that into account too. All right, let's try the first one on the calculator. It says that we're going to throw a ball straight up. Has an initial velocity of 80 feet per second. Now we're throwing it up from ground level. So what does that mean by initial height is going to be? 0. Yeah, initial height is going to be 0. All right, so there's an equation that represents this problem. So I filled in 80 for v sub 0. Okay, that's my initial velocity. For s sub 0, I filled in 0 because there is no initial height. Okay, so any questions on how I got that? So we're going to figure out when is the ball at least 64 feet above the ground. Okay, so not exactly 64, but at least 64. What does at least mean? If you think of it in terms of one of our 4 inequality symbols. Yeah? Right, we're going to find out when the height of the ball, when is the height greater than or equal to 64? So the first thing we need is an expression that represents the height. Well, that is that part I just underlined in red. Okay, negative 16t squared plus 80t. Okay, so when is the height, that's the formula for the height, above or equal to 64? So what we'll do is we'll graph it on the calculator. We're going to use y1 and y2. And we'll graph it and then kind of take a look at what it looks like and then go from there. All right, so let's do negative 16. Remember, use x as your variable. Plus 80x and 64. All right. If we graph y equals 64, what's the y-intercept of that line? Well, Ryan, what's the y-intercept of that?
Wouldn't it just be 0?
That would mean that it's going to be on that line would be a horizontal line on the x-axis, but that one's not on the x-axis.
Wouldn't it just be 64?
It would be 64. That's a horizontal line 64 units up. So we definitely want to set our y max higher than 64. Okay, I would probably go, I don't know, maybe to like 90. Okay, we're talking about two variables. T is time, which we're using x, and the height is y. What kind of numbers would not make sense for either height or time? Yeah.
Anything below 0.
Yeah, we don't want anything below 0. Definitely don't want negatives. Okay, so let's try setting our window like that and see what we have. Okay, I didn't go high enough. I'm going to see the 64, that's good. But if I want to see the top of the parabola, let's try going up maybe like 100 and, I don't know, 120. Okay, so that's good. So the goal is to figure out when the object is above 64 feet. Okay, using that graph, what do you think I'm going to have to figure out now? Yeah.
Intersection.
Yep, I'm going to need the two intersection points. So let's do second calc intersect. All right, so there's one. Okay, put that one over there. And let's do second calc intersect. This time I got to be a little bit more careful. I got to move my cursor closer to the one that I want. Okay.
Could you do the intersecting?
Yep, so we press second, calc, and then option 5. Second, calc, and then option 5. Calc is right up at the top. I think is it the button that says window?
This is trace.
Trace. Yeah, it's the one that says trace. All right, so I've got both my intersection points. So the x value represents time. So how would you explain here when this object is at 64 feet or higher? Yep.
X is greater than or equal to 1, and x is less than or equal to 4.
Yeah, so x is greater than or equal to 1, and x is less than or equal to 4, or we can say it as a compound inequality, like that. So that really means between 1 and 4 seconds. Okay, before 1 second, it hasn't gone high enough. After 4 seconds, it's already on its way back down, and it's gone below 64 feet again. Okay, so when is the ball at least 64 feet above the ground? Between 1 and 4 seconds. And I can just put seconds, and that's also in seconds. Okay, is there any question on that one? All right, so that was solving a higher order inequality using the graph. We're going to look at now doing it a little bit different. Okay. So now let's try using some algebra. Okay. Next question is same condition, same problem. When does the ball basically hit the ground? Okay, how long is it in the air for? So if the ball is in the air, then we know the height of it is what?
Greater than 0.
It's greater than 0. So we basically want to find now, when is the height greater than 0? Okay. Equation was negative 16t squared plus 80t. When is that above 0? Is there any question why having a height above 0 means that it's in the air? Okay, so let's solve that, but this time we're going to use algebra. We don't need quadratic formula because this one's going to be a little bit easier. The reason we don't is because there's no constant. So what do both terms on the left side have in common? Yeah.
They're both multiples of 8.
Okay, they're both multiples of 8. Are they multiples of anything that's even a little bigger?
16.
16. So we can factor out. We can factor out a 16. Okay, I'm even going to factor out a negative 16, just because I like the squared term to be positive for what I'm going to do next. So let's factor that out. Is there anything else that both of those have in common, besides being multiples of 16? About 8? Look at the variable.
So like, are we trying to find just multiples of 16 or?
No, we're factoring them. We're going to factor out what both terms have in common.
T and
T and negative, we already got negative
Okay.
16. So we're going to factor out negative 16t. Nick, when I factor that out from the first term, what does that leave me with?
Just T.
Just t. And how about Lizzie, when I factor that out from the second term, what would that leave me with? Negative 5. Yep, just negative 5. All right, so now we have it factored. We have something times something is going to be greater than 0. Let's think about this first factor. This first factor right here, t is always going to be what kind of number? Yep.
Negative?
T.
Oh.
T is always going to be what kind of number? Yeah?
A positive number.
Or 0. Yeah. So t is always going to be 0 or higher. This is t. If you plug a number in 0 or higher for t, what does that mean what's in the parentheses is always going to be? Yeah?
Anything above 0, it's going to be a negative number in the parentheses. And if you plug in 0, it's going to be 0.
Right. So what's inside these parentheses, this whole thing, is always going to come out 0 or lower. It has to, because you're plugging in a number for t that's 0 or higher and multiplying it by negative 16. So this is always going to be 0 or lower. Right? So in order for this to come out greater than 0, right? Well, this can't be 0, because if it was 0, 0 times anything would be 0, and 0 isn't greater than 0. So the other case that can happen, where I circled in blue, is it comes out negative. Right? So that's the only chance of this equation having any solution. Right? This is going to come out to a negative. What would have to be next to it in parentheses? Right there, for this to be true. There's only one way that a negative times something can come out greater than 0. If you have a negative times a,
Negative.
you need another negative. Okay? So in other words, t minus 5 has to come out to a negative number. Right? Let's write that down. So this implies t minus 5 has to be less than 0. If it's not going to come out negative. And when you solve that for t, what do you get? But Waylon, what do you get?
T is less than 5.
T is less than 5, exactly. So that answers the question. How long is the ball in the air? Just under 5 seconds. Time is, so it's in the air like 4.9 repeating. When you get to 5, it hits the ground. Okay, so it's in the air just under 5 seconds. Any question how we figured that out? Okay, once we factored it, we had to kind of reason it through. The first thing was always going to be negative. So a negative times a what is going to be greater than 0? It has to be a negative times a negative. So that to get from this step to this step, it wasn't really algebra that we did. we kind of just reasoned it through that t minus 5 has to be less than 0 to make this true. All right, so that one wasn't too bad because we could solve it by factor. And I didn't multiply or divide each side by a negative, so I didn't have to worry about anything like that. So the question we had to answer is, when is t minus 5 negative? I already did that up above. Okay, it's when t comes out less than 5. Okay. And then when is the ball at least 64 feet off the ground? We already did that with the calculator. I'm not going to do it algebraically right now, so I'm going to hold off on part B because I'm going to show you how to do it algebraically, but I'm going to do a different question. Okay, I've done enough with this one. And the way that you can solve something that may not be as easy to think about, okay? It's not something that you can factor out a GCF, but you have to factor it with 2 sets of parentheses. Okay, a little more complicated factoring. We're going to use what's called a sign pattern. So when you factor something, okay, and you factor it into linear factors, okay, linear factors are like x minus 1, okay, x plus 4, x minus 7. Okay, something that just has a variable to the first power, and then plus or minus a number. When you factor something as linear factors, there is exactly one number you can plug in that would make that factor 0. Now, if you have quadratic factors, that's different. Okay, we're talking about linear factors, something to the first power, plus or minus a number. There's only one thing you can plug in that would make it 0. In the first factor, if you fill in a 1 right there, you'll make it 0. And that's the only number you could fill in. If you fill in a negative 4 here, you would make that factor 0. And that's the only number you could fill in. So if you plug in, let's look at the first factor. If you plug in 1, you get 0. That means if you plug in anything greater than 1, you're going to get what kind of number? If you plug in something greater than 1, right there. Yeah,
Positive.
you're going to get a positive. What if you plug in something less than 1? Right there. Yeah, you're going to get a negative. So that's the whole key of using a sign pattern. You have to figure out what numbers can you plug in that are going to give you a positive, what numbers can you plug in that are going to give you a negative. And the way you figure that out is you first figure out what number can you plug in that gives you 0. That's the number that's going to be anything bigger than is going to give you something. Anything less than will give you the opposite. Okay. So doing a sign pattern relies on factoring. Okay, we do have to know how to factor. Okay. Once we factored it, what we're going to do is we're going to make a number line. Okay, the number line, it's more of a visual, so we can kind of see what's going on. So like if I was going to do it for the top one, make a number line. I'm going to mark the number on my number line. That gives me 0. And once I do that, I've split my number line up into 2 sections. There's the first section. There's the second section. Less than 1 and greater than 1. Now I have to figure out what happens in each section. Okay. So determine whether you're positive or negative in each section. Okay, so we just said if I plug in a number smaller than 1, that's the negative section. And if I plug in a number bigger than 1, that's the positive section. Okay, and then you do it again for your other factor. Mark the root on the number line. If you plug in a number smaller than negative 4, you'll be negative. Bigger than negative 4, you'll be positive. It's not always negative on the left, positive on the right. A lot of times it is. But if you had something like this, if you factored something and you had a negative in front of your letter, that would reverse everything. So I'm not gonna do that right now. Okay, so you make number lines for each factor. Usually there's 2, sometimes we'll go up to 3, but that would be the most factors. Okay. And then leave a little bit of space, because I have one more thing that's about that long that I'm going to add. But I want to do an example just up to this step so you can see how it works. Okay, so I've got one more thing I'm going to add in a second, but let's start to solve this one just up to that last step. Okay, so it's a quadratic inequality. And again, this method is only going to work if you can factor the problem. If you can't factor it, this whole method I'm showing you right now doesn't work. All right. What's going to be my first term in each set of parentheses when I factor that? Yeah.
X.
Okay, an x and
2x.
a 2x. Yep. What's going to be my signs in the parentheses? Positives, negatives, or one of each? Yep, we're going to need one of each. It does matter where you put them. If you put them in the wrong slot, you might have to switch them. And now I need 2 numbers that multiply to give me 5. Kaylee, 2 numbers that multiply to give me 5? 5 and 1. And which one would you put here?
1.
Yes. Put the 1 there, and the 5 there, and let's check it. 2x squared. 2x times 5 is 10x. Take away 1x is 9x. Perfect. So we factored it. Lucas, how many factors did I get there?
Linear factors?
Yeah, how many linear
2.
factors? Yep, I have 2 linear factors. Linear means that I just have a letter, it's to the first power, and then plus or minus a number. So we're going to make 2 number lines. We're going to make a number line for the 2x minus 1. We're going to make another number line for the x plus 5. What's the root of that first factor? What could you plug in for x and it would give you 0? Yep. 0.5. Yep. So mark the root, 0.5. Let's do the bottom one. What could you plug in for x to make that 0? Yep. -5. And now let's determine what happens in each section of the number line. One part's positive, one part's negative. If you plug in a number smaller than 1/2, right there, what kind of value will you get for the whole thing I just circled? Smaller than 1/2. Yep. Negative. Like pick 0 and just plug it in and try it. Negative. What if you plug in a number bigger than 1/2, like 2 for x? Yep. You get a positive. Okay, so now we know the numbers you can plug in that give you negatives and positives. Right. For the top factor, let's do the bottom one. What if I plug in a number smaller than -5, like -8? What would I get for my number there? Yep.
Negative.
Again, negative. And if I plug in a number bigger than -5, like 0, I would get a positive. Okay, so that's the directions up to the step that I've given you so far. Any questions on the number line? Now, the last step is to take those 2 number lines and combine them together. So once you've created your number line for the individual factors, we're going to combine them together. because what we want to look at in this problem is the result of a product. This times this has to be bigger than 0. So there's different cases that could happen. We could have a negative times a negative be greater than 0, or we could have a positive times a positive be greater than 0. But this whole method of using a sign pattern, we're never really solving and having to worry about like dividing or multiplying by a negative, because that would cause us to flip the sign. Okay? That gets a little complicated to think about with quadratics. That's why we use this method. Okay, so once you have a sign pattern for each individual factor, yeah, that should say for the individual factors, now we're going to combine these together into one. Okay, when we combine them together, we're going to put both roots on the same number line. -5, 1/2. How many sections did that split my number line up into? Check. 3. And my goal is to figure out the signs there. Are they negatives or positives in those 3 sections? And when I'm done, I want to look at the sections that come out positive, greater than 0. Okay. So let's start by looking at what happens if we are below -5 in both factors. So if you want, you can kind of temporarily just put a mark right there. That's -5. On the top number line, if I am lower than -5, what kind of numbers am I going to get? Yeah.
Positive. Because a negative times a negative is a positive.
So in the top, just in the top number line,
Okay.
if I'm below -5,
Negative.
I'm in the negative section on that top number line. So I would have a negative times, now look at the bottom one. If I'm below -5 in the bottom one, what section am I in? Well, voices. Negative. So I'm in the negative in the top, I'm in the negative in the bottom, and I want to know the product of a negative times a negative, which would be,
Positive.
that would be a positive. Now let's look at between -5 and 1/2. Jack, in the top number line, if I'm between -5 and 1/2, what section am I in? Oh, I'm sorry, Jack. Yeah.
Oh, B?
Yeah.
Positives?
Positives would be over here. So is -5, let's pick a number between -5 and 1/2, 0. Would 0 be in this section?
No, it wouldn't.
No. Between -5 and 1/2 is right here. Okay, you would be in the negative section. How about in the bottom number line? If you were between -5 and 1/2, what section would you be in? Yeah. Positives. You'd be like right in here somewhere. And if you multiply them together to get the product, because that's what we're doing, multiplying them together, a negative times a positive is a negative. So if you pick any number between -5 and 1/2, and you fill it into the original problem, I guarantee it will come out negative as an answer. Now let's look at bigger than 1/2. Okay, top number line. If I am bigger than 1/2, what section am I in? About a minute.
What was the question?
Bigger than 1/2.
Positive.
Yep, we're positive. How about in the bottom number line? If I'm,
Is it not still positive?
that would still be positive, yep. So in bottom number line, 1/2 would be like right around here. Anything bigger than 1/2 is positive. So you get positive in the top, positive in the bottom. And we're looking at the product of the two, which is positive. Okay, so that's the hard part. Okay, figuring out where this entire thing comes out positive and negative. Last thing we have to do is just figure out what do they want. Well, they want to know where it's greater than 0. That means positive. How many sections on that final answer come out positive? Yeah? 2. 2. Anything lower than -5. Now, whether or not I can include the -5 depends if the original problem had it equal to. No. The original problem was a greater than. So I can be lower than -5, or I can be higher than 1/2. That's the answer to the question. If the original problem had said, where are you less than 0? Well, that would be the section between -5 and 1/2. But this one said greater than 0. Okay. Any question on that one? So you're still finding the roots, which we talked about a lot last week. Because these are the roots. You just have to figure out, once you know the roots, it breaks your number line into sections, which sections are positive and which sections are negative. And that's what these individual number lines kind of help you to figure out. Let's try this one. So this is a cubic, but it's already factored for you. How many linear factors are on the left-hand side? Lucas?
2.
Okay, what are they?
X plus 3 and x minus 1.
Nothing else on the left-hand side?
And x.
And x. That's also a linear factor. You could think of it as like x plus 0. There's just no plus or minus a number. So we're going to make a number line for each one of those factors. How about Joe? What would be my root for that factor?
0.
0? Yep. Okay, for the second one, x plus 3. Cole, what would be my root there? 3 plus 3 would give me 6. -3. And Waylon, what would be my root for the bottom one?
Positive 1.
+1. Okay, so now figure out your signs in each section. All right. Cami, if I plug in a number smaller than 0 to the top factor, what kind of number would I get? Yep. Negative, positive. How about in the second number line, if I plug in a number smaller than -3 into x plus 3, what would I get? Smaller than -3 into x plus 3. Yeah. Yep, you get a negative. Okay. How about bigger than -3 into x plus 3? Right? Yep, positive. All right, and the bottom one? What if we plug in a number smaller than 1 into x minus 1? Michael?
Negative.
Yep, we get a negative. And then what if you plug in a number bigger than 1? Right there, you get a positive. Okay, so we're going to combine all that together. And when I do combine it and put all those roots on the same number line, how many sections is that going to split the number line into? Yeah, 4. Yeah, it's going to split it up into 4 sections. So we've got -3. We've got 0. And this isn't to scale, it's just a picture to get the idea. And +1. So we got to figure out what's going on in each section. And I will give you a hint, it always alternates. So it's either negative, positive, or positive, negative. So once you figure out the first section, you kind of know everything. But let's do the first 2, just to get the idea. Okay, smaller than negative 3. We're going to have a what times a what times a what. If I am lower than negative 3 in the first factor, what section am I in? Yeah?
Negative times a
Negative.
times a negative.
How about if I'm lower than negative 3 in the second section?
Negative.
That's a negative. And lower than negative 3 in the third section.
Negative.
And when you multiply all those negatives together,
Negative.
you get a negative. Yep. Okay, let's do between negative 3 and 0. What if I'm between negative 3 and 0 on the first number line? What section would I be in? Right? Negative. How about between negative 3 and 0 on the second number line? Yeah,
Positive.
that's a positive. And what about between negative 3 and 0 on the third number line? Yeah, negative. And we're looking at the product of all three. Negative times positive times negative is going to give me an overall result of positive. Okay, so it is just going to alternate. And now we have to scroll back up and remember, what did they want? They want to know where we are greater than or equal to 0. How many sections on the number line are going to come out greater than or equal to 0? Yeah? 2. This one and this one. How would you write the numbers in that section? Between negative 3 and 0, and remember, it's greater than or equal to. Yeah?
Use brackets, -3, 0, and then the or sign, then bracket on 1, and then infinity.
Perfect.
Parentheses.
Perfect. So that's the solution to this problem. You can pick any number between negative 3 or 0, including, or you can pick a number 1 or higher. And if you plug it into the original problem, you will get an answer that is greater than or equal to 0. Okay, any question on that one? Okay. Division is really the same thing. If this problem was x minus 4 times 2x plus 5 is less than or equal to 0, the answer would be almost exactly the same. There's just one thing you have to remember when you're doing division. What are you not allowed to do?
Divide by 0.
You can't divide by 0. So keep that in the back of your head. All right, so the root here is 4. The root here is negative 5 over 2. Negative 2.5. If you plug in a number lower than 4, negative. Higher than 4, positive. Lower than negative 2.5, negative, positive. When you put it all together, so far, whether we were doing the problem in red or the problem in black, we've done the same thing. Even this step is still going to be the same. Negative 2.5, positive 4. Since the rules for dividing and multiplying are the same, this answer right here is going to look exactly the same. If you pick a number below negative 2.5, you'd be in the negative section and the negative section. So that would come out a negative divided by a negative is a positive. If you pick a number between negative 2.5 and 4, you'd be in the negative section. And then here you'd be somewhere around there. That's the positive section. Negative divided by positive, negative. So up to this step, everything is the same. The question is asking, where are we less than or equal to 0? How many sections on that number line come out less than or equal to 0? Yeah, just one. And you might think, well, it's just everything between negative 2.5 and 4. And you can include it because it has the equal to. If it was the problem in red, I would say yes, you can include -2.5 and you can include the 4. But because it's division, one of those numbers can't be included. And it has nothing to do with the sign. It has to do with dividing by 0. Which number between -2.5 and 4 do we need a parenthesis on? Yep.
-2.5.
Right. You can include the 4, that's fine, because it wasn't equal to, but don't include the -2.5 because you divide by 0. Okay, so that's the only thing that's different with division. It might cause a bracket to turn into a parenthesis if you could have division by 0. If that equal to wasn't there, you would have avoided that whole problem. Because if it wasn't there, you would have used parentheses on both numbers anyway. All right. All right, so last one we'll look at in this section is another one on the calculator. So if it's not possible to factor it, you're not using the sign chart method. It's not going to work. So what we'll do is, let's do this one on the calculator. There's a couple ways we can do it. Let's just put everything in the left in y1, and then we'll put what's on the right in y2. All right, so let's do x cubed minus 2x squared minus 5x plus 7. And on the right, I'm going to do 2x plus 1. I'll put that in y2. So 2x plus 1, that's like y equals mx plus b. That's a line. So I want to look where the blue graph is above or equal to the red graph in my picture. Where is the blue above the red? Okay, and I'll do zoom 6. And just so we remember, that one's in blue, that one's in red. Okay, so let's take that picture. Let's put that over here. And we're looking for where blue is above red. First of all, is the blue ever above the red?
Yes.
Yeah, definitely. How many times or how many sections is the blue above the red?
Twice.
Twice. I would say in this section, I'll just make it kind of bold, right there. And where else is the blue above the red? James?
And over up more. It's like it goes above the line when it's converting upwards.
Yeah, right on the right-hand side.
Yeah.
This is just going to keep going up, and that red line is not as steep, so the blue is always going to stay above the red. Okay. Do I want to know where it's above or above and equal? Yeah?
Above and equal.
Above and equal. So I need to find all three of those intersection points. So we'll do second calc, intersect. And which number is important there when I write an interval? Is it the x or the y that I'm using? Well, look at what variable we're solving for in the inequality. Yeah?
X.
It's the x. So to solve this equation, I need to be between negative 2.26, and I can include it because it said above or equal, and I can go up to this other intersection point. If somebody can find the intersection point all the way on the right, I need that one in a second. 0.76.
3.51.
It's 3.51
For the final one.
for the final one, so I can go 3.51 up to
Infinite.
infinity. Yeah, this is a unbounded interval. That's a parenthesis right there.
Yeah, we'll close the issue.
Because that's exactly the same thing we did with a sign pattern. It's just that's a cubic. It's probably going to be a lot harder to try to factor it. So we do it this way. Any questions on that? Yes?
Now, would it be for every variable that goes up, there's another intercept point?
Not always. Because if I were to graph something like this is a cubic, I'm not going to do it all out, but if I had x plus 1, and then I did x plus 1, and then I did x plus 1, let's say I typed all that in, what number would you plug into the first factor to make it 0?
-1.
How about the second factor?
-1.
And the third factor?
-1.
So what we have there is a repeated root. That's a triple root. So in this case, no, it is not going to cross the x-axis 3 times. It's only going to cross 1 time at the number -1.
But like, would it have a max of 3?
Yes.
Okay.
Yep. That exponent does guarantee it will not cross more than 3 times.
Okay, but it will not say how many minimum times it will cross.
Yeah.
Well, we'll always cross once.
Well, with an odd degree polynomial, yes, cubics always have to cross at least once compared to parabolas. Parabolas don't have to necessarily cross once.
Yeah.
Yeah. We're going to learn more about that kind of stuff in chapter 3, which we're going to start talking about right now. All right, so the last thing we're going to take a look at is a little bit of section 3.1. We'll see what we get to. And it's about polynomials. So polynomials in general are any type of equation that have variables. They're raised to powers that are integers. And then what happens is the exponent usually, if you write it in descending order, goes down 1 each time. Like 3x to the 5th plus 2x to the 4th minus 3x to the 3rd. Yeah, and sometimes you skip. You might not have every exponent. But it usually ends with a constant, unless the constant's 0. But the key is all the exponents that you put on your variables have to be integers that are not negative. You can't do x to like the 5.2 power. That's not a polynomial. So quadratic expressions, those are polynomials. Y equals mx plus b, those are polynomials. And this just represents the highest exponent usually. You don't have to put the highest exponent first, but it is generally good practice to always put the highest exponent term first. Now, this polynomial, I can describe this using a word that begins with D. And this particular one is a 5 that I wrote up there. Does anybody know the word I'm thinking of that describes this polynomial? Begins with a D. And in this one, the word I'm thinking of that begins with D is a 5.
I don't think it's right.
Yeah?
But derivative?
No, not derivative. It's something we won't talk about, but you will next year if you take calculus. What's the word you use to describe the highest exponent in an expression? Yeah? Degree, yes. So as long as the first term isn't as multiplied by 0, like if you do this, 0 times x to the 4th plus 3x squared minus 5, you wouldn't say the degree of that one is a 4. What's the degree of that one in blue, really? Oh, Nick? Nope, because the 4, that doesn't even exist, because it's being multiplied by 0.
So 2.
2. All right, so the degree of that would be a 2. What do you call it if it's a degree 2? What's the name of it? Yeah?
Quadratic.
Quadratic. What do you call it if it's degree 1? Yeah?
Linear.
Linear. How about degree 3? Cubic. Yep. So some degrees have special names. Degree 4 is quartic. But usually when you get above degree 4, they would just say it's a polynomial of degree 7, degree 10. I'm sure there are names, but those are the most common names we use for degrees 1, 2, and 3. Nice thing about polynomials, the domain is really simple. The domain is all real numbers for every single polynomial. And that's because by the definition of a polynomial, you cannot have a square root with a letter under it. So you'd never be taking square roots of negatives. And you cannot have a fraction with a letter in the bottom. If you do, it's not a polynomial. So domain of every polynomial is all real numbers. The range depends. It really depends on whether it's an odd degree or an even degree. So that's what a cubic looks like. I know we've looked at them before. Cubics can cross the x-axis, and we just talked about this a few minutes ago, up to 3 times. But they might only cross twice or once. If this was your x-axis right here, that's how you could get twice. If your x-axis was here, that's how you could get 3. And it knows that's how you can get 1. Could you get 0?
No.
No, not with a cubic. Because they go up forever and they go down forever, and they're always connected. So it will go through 0 at some point. Those are cubic. 4th degree polynomials could have that kind of pattern. Again, some of these terms might not be present. Like you could have just this. And that's a 4th degree polynomial. That's the simplest one you could have. There's no cubic, squared, linear, or constant terms in it. Just one term. Now, 4th degree polynomials, if you put a line like this, you can kind of see the different cases. It could cross the x-axis up to 4 times. You could get 3 times. You could get 2 times. You also could get 1 time or no times. So you could get every possibility between 0 and 4 when you have a 4th degree. And not every 4th degree takes all those terms, just like not every cubic takes its terms. Some 4th degrees, in fact, the one I just put on the board, y equals x to the 4th, kind of looks like a parabola. The difference is it's flatter on the bottom. Okay, but it's going to look kind of like a parabola. When you start adding in all these other terms and making it more complicated, that's when the graph starts doing more complicated things and taking all the twists and turns. Okay, so let's look at this one. And they want us to find the domain and the range. What's the domain of that polynomial? Yep. All real numbers. You will never divide by 0, and there are never any square roots in them. So domain is all reals. I didn't say how to write it, so I wrote it both ways. Now the range depends. When you have an even degree polynomial, that's when you really need to be more careful with the range. So let's what is the degree of this polynomial? Yep.
4.
Yep, it is a degree 4. So plus 5x cubed. Because it has a lot of terms in it, this one's probably going to be more complicated, and it's going to do all the twists and the turns. So it'll probably have a W shape to it overall. You should probably, if you didn't hit graph yet, you should set your y min. I would do maybe -20. Now, does this graph go up forever and down forever?
Only up.
It only goes up forever. Then that means it must stop going down at some point. Where does it stop going down? How would we figure out the lowest that it goes? Yeah?
Minimum.
Yeah, we're going to find the minimum on that left-hand side. So second calc minimum. And it's going to ask you 3 questions. Pick a point to the left, to the right, do your guess. Okay, now I'm finding the range. Am I interested in the x or the y value of the coordinate at that minimum point? I'm interested in the y. How low does this graph go? And it goes right down to -11.95. And we can include that because it does hit it. Okay, so -11.95. And how high does the graph go? About one there? Infinity, yeah, it just goes up forever. Even degree polynomials always have infinity somewhere. They either go up forever or they go down forever. They don't go, not both, one or the other. We'll talk more about that, but that's just kind of a hint. So there's your domain and range. You can look at 5th degree polynomials. 5th degree polynomials can cross the x-axis up to 5 times, which means they can turn 4 times. So a 5th degree polynomial could look like this. 1 turn, 2 turns, 3 turns, 4 turns, and there you go. 1, 2, 3, 4, 5 times. 1, 2, 3, 4 turns. That's how you could get 5 crossings. Yeah.
So is it that every odd polynomial goes both directions,
Yes.
whereas every even goes in the correct?
Yep. Odd polynomials always go up and down forever. Even polynomials do one or the other. Yep. So,
And then just is doing like much more complicated tricks in between.
yeah, depending on the complexity of all the terms in between can control how complex the graph looks. Now, all of these things that I just circled, these are what we call local extrema. They're areas of the graph that are higher or lower than everything else around it. I am not saying that this is the lowest the graph ever goes. I'm saying in this zone, this point is lower than everything else around it. Okay. So local minimums and local maximums are points on a graph that are either higher or lower than everything around it. This is a local minimum, that's a local minimum, that's a local minimum. None of them are what we would call a global minimum, because this one doesn't have a global minimum. It goes down forever. So I guess you could say it goes as low as -infinity. Okay, so these 3 things I circled are local minimums. These 3 things are local maximums. They're points that are higher than everything else around it. So if you see a question that says, find all local extrema, what they're asking you to find is all the minimums and maximums on a graph. And the way that we do it is with the calculator. You definitely don't need the calculator, right? You'll learn more about it next year if you take calc. But if you were standing right here, exactly at the maximum, how steep do you think it would feel like if you're standing right on the maximum? How steep do you think it would feel like it is right there? I think if you're standing at the top of a hill that was just like that. Yeah.
Flat.
It's perfectly flat, which means it has a slope of what? 0. So if you know that the slope is 0, which it is, at every local minimum and maximum, you can use a derivative to figure out all those things we're going to do on the calculator. But you just have to understand that the slope is 0 right there. But we're going to stick to using the calculator. All right. Any question on definition of local minimums and maximums? Okay. All right. So let's see if we can find the local minimum and where it occurs. So that's an important distinction. What is the local minimum? Where is the local minimum? If you see a question that has to do with what is the local minimum, that means what is the y value? How low does it actually go? Okay. If they're asking you where that value occurs, they're asking what number would you type in for x that would give you that y value. Okay, so what the local minimum is y. Where it occurs is the x. Let's type in x cubed minus 4x and do zoom 6. Okay, so this particular graph only has one local minimum. Second, calc minimum. Pick a point left. Pick a point to the right and do your guess. Okay, so based on that, what is the local minimum? What is the local minimum in that graph? Yeah.
Negative 3.08.
Negative 3.08. So the local minimum is negative 3.08 and occurs when x is 1.15. That's how you would answer that question. What the local minimum is and where it occurs. And then local maximum, I'm going to skip that one, but local maximum would be the same thing. Second calc maximum. I think this one is symmetrical.
Yes.
Yeah, so I think like it's negative 1.15, positive 3.08. They're not always symmetrical like that, it's just, that's how this one is. Okay. Any question on how we found that local min? So you definitely need a calculator the way we're doing it. All right, do that one. All right, so the last thing is looking at this graph. I've marked 4 points on it. And once you can figure out local mins and maxes, that ties in with this idea of increasing and decreasing. Where is this graph decreasing? Between, and I didn't put numbers on these mins and maxes. Well, B and C are mins and maxes. But it's decreasing from what to what?
From point A to B and from point C to D.
Yeah. And where is it increasing?
From point B to C and from B to A.
from B to C.
It's increasing from B to C.
Yes.
Yeah.
That's the only interval where this graph is increasing from B to C, and it was decreasing from A to B and C to D. Remember, increasing means it's going up to the right, decreasing means it's going down to the right. To figure out where a graph is increasing or decreasing, all you have to do is find the mins and maxes. And once you know those, you'll have the location that you can use to describe from that point it's increasing or from that point it's decreasing. All right, so I'm going to finish up. I'm just going to use the last problem we just had because we already found one of the local minimums. Put that one back up. And let me make it bigger. And let me move it down. Okay. So instead of just wording and saying find the local mins and maximum, let's find where this is increasing. So where is this graph increasing? Okay, well, it's the same idea as what we just did. This graph is increasing. Let's label this coordinate. It's negative 1.16. I just know that because I found it before and I remember it. So it's negative 1.16.
Wouldn't be maybe 1.15.
Yeah, negative 1.15, yeah, if we round it properly, thanks. And then it's up 3.08. Okay. So how many intervals is this graph increasing on? How many sections are we going to have to describe that are increasing? In other words, positive slope. Yep. 2. How would you describe this interval from here to here?
Negative infinity to minus 1.5.
Yep. When you describe that interval, just like we always describe intervals, you use the x's. So it's increasing over those numbers. And I'm just going to write decreasing. Where is this graph? Oh, yeah, sorry, there is one more increasing, I think you were going to say. Where's the other one?
And then that's the other point, which I forget exactly.
It's right there.
Oh, okay. Which is 1.15 to 50.
Mhm. And where is that graph decreasing?
Negative 1.15 to 1.15.
Yep, exactly. Okay. So finding where it increases and decreases relates to finding mins and maxes. Okay. All right, so that's homework for tonight. A lot of it is on the calculator, especially in the second section. Also, notice on the 16 to 20, those are evens. So just 16, 18, 20. All right, so that's 2.5 and 3.1. So tomorrow we'll take a look at that, go over the homework, and then if there's questions, we'll do those, and then we'll do 3.2 tomorrow. And I plan on being after school on Thursday, if anybody needs to come for extra help.